Hello and welcome to today's presentation. In today's presentation, I'm going to talk about the difference in difference research design. This might be your first time hearing about this research design, or maybe you might have heard about DID but do not know how to apply it or when to use it in your research work. This presentation is going to provide you an overview of this research design and then give you a deeper understanding about experimental research. So by the end of this presentation, we will basically talk about what DID design is, the assumptions underlying DID research design. We will look at the regression model for DID. We also consider the strengths as well as limitations for using a DID design. And then also I will introduce you to some top papers that use DID approach. So based on the papers that I will introduce to you, you can do a further study by downloading these papers and then read more about DID and get a detailed or a deeper understanding about this research design. So when we talk about DID, what do we mean by a DID research design? Difference in difference is a quasi-experimental design that makes use of a panel data from treatment and control groups to obtain an appropriate counterfactual to estimate a causal effect. What do we mean by a quasi-experimental design? In the area of research, and most especially in academic research, there are different approaches that we use or different research designs. Some research may require you to do a survey, and others also may require you to conduct an experiment. But in experimental research, we have what we call a quasi-experimental research design. And a quasi-experimental design aims to establish a cause and effect relationship between an independent and a dependent variable. So unlike controlled experiments, a quasi-experiment does not rely on random assignment. Instead, objects are assigned to groups based on non-random criteria. So like I mentioned, we have different types of studies, and for controlled experiments, we assign groups into two, that is one for treatment and one for control group. But this assignment is done on a random basis so that our groupings will not be biased or will not suffer from being biased. What do I mean by this? In a practical sense, for instance, if a company has developed a COVID-19 vaccine, for instance, and we want to test the potency of this vaccine, then it will be better we do a randomization to sample some people to test this vaccine on. In that case, practically, it means that we want to test the effect of the COVID vaccine, not considering some key factors or not considering a particular group of people, but we want to test whether this vaccine will be able to help people who be infected, no matter the age, no matter the sex, whether male or female, no matter the person is pregnant or not pregnant. We just want to test. So in this case, we can just use randomization to do our assessment on the effectiveness of the COVID vaccine, and this will not be we will not have any issue of selection bias in this case. Okay, so for such controlled experiments, assigning groups into assigning people, or let me say groups, into treated and then control groups is done randomly. Okay, but there are some instances that doing this randomization is practically impossible. So we have observational studies where assignment into groups and control group is not what random. And an example is a situation where let's say a firm wants to conduct a training program for physically challenged staff or employees. In this case, the training program will be designed specifically for physically challenged people. In that instance, our target group, that is the physically challenged workers, are already known. Okay, so there is no need for any randomization here. We just give them the treatment, that is, we just assign these workers to the training program, and at the end of the training program we test the performance of the staff, whether the training had a significant impact on the staff performance or not. So for this experiment, we could see that practically we cannot do any randomization because we know our target group, that is the physically challenged staff. So we can use DID in this situation to test the impact of the training program on the performance of the staff, and then use the other staffs that are not physically challenged as a control group, and then compare it to the treatment group, that is the physically challenged staff. So this is a typical example of a quasi experiment. So in this case, we can use a DID design to assess the impact of the training program on staff performance. So that is what we mean by a quasi-experimental design. So in DID, we usually make use of panel data from a treatment and a control group in order to obtain an appropriate counterfactual. Going on, I will be mentioning treatment group and control group. When we say a treatment group, what do we mean by a treatment group and a control group? When we say a treatment can be a training program, it can be a policy, it can be a law or a regulation that is being enacted by a body. So in DID research design, there is always a treatment, and the treatment may represent a policy, it can be an intervention, it can be a program, or any other external shock or any other external event that has an impact on a particular firm, on a particular industry, or on a particular target or social group that we want to do what? That we want to find the impact of that particular treatment. Okay, so we will do a lot of treatment evaluation. When I say treatment evaluation, we mean that the estimation of the average effects of a program or treatment on the outcome of interest. So basically, we are just doing evaluation of this treatment, of the policy, of the intervention or the program that has been introduced, and then compare the outcome between treated and then control observations. Okay, so an example could be, let's say, the introduction of an accounting standard by an accounting body. So in DID, we can use DID research design to test the effect of an accounting standard or laws on earnings management or on revenue or other accounting variable, which could be earnings, which could be, let's say, acquisition of debt, which could be cash holdings. Okay, and another example is where we want to test a program by the government. Let's say that there's a school feeding program by government, and we want to test the effect of this program by the government on students' performance. So this is also an example of a treatment that we can use DID research design to test the effect of this treatment on other outcomes. So DID is typically used to estimate the effect of a specific intervention or treatment, such as a passage of law, as I mentioned earlier on, enactment of a policy, or large-scale program implementation, by comparing the changes in outcomes over time between a population that is enrolled in a program, that is the intervention group, and a population that is not enrolled in the program or in the particular program. In that case, we refer it to as what? The control group. To see the difference between the performance of workers who are physically challenged and workers who are not physically challenged. So, as I said, this is the type of research that we term as what? A quasi-experimental research. So, a quasi-experimental research design is a useful tool in situations where true experiments cannot be used for ethical or practical reasons. Okay, so in DID, or difference in difference research, is a type of a quasi-experimental design. Most often, our target group is known, so assigning treatment to group is not done on a random basis. And in this presentation, I'm going to mention treatment control, treatment group, control group. What do we mean by a treatment? Or when we say a treatment group, what are we referring to? A treatment can be any program, any intervention, any passage of law, any policy that has an impact on a particular variable. So if you are looking at a group that took part in a certain program, or a group that was affected by a certain policy, or a group that was affected by a certain program, then we say that group is a treatment group. Okay, and the other group that was not affected by the program or any policy or any law that was enacted, we refer that group as what? As a control group. So in terms of evaluations, most often we would want to know the impact of that particular intervention or that particular treatment on the target group as well as the non-target group. So treatment evaluation is the estimation of the average effect of a program or treatment on the outcome of interest. And basically, this is done for comparison of outcome between the treated and the control observations. So, for example, like I cited the situation of what? Designing a program for physically challenged workers, and then assessing the effect or the impact of this program on their performance. Okay, another example is looking at the effect of an accounting standard or accounting standards or laws on earnings management. Okay, when these laws are enacted by international standard bodies, these laws affect the operations, or let me say, it affects the preparation of financial statements. And therefore, if such laws come into place, we would want to use a quasi-experiment, or we want to use a DID design to ascertain the impact of this law that affected a section or a particular company's reporting, and then also compare it to the impact of such reporting on firms that were not affected by what? Those standards or those laws. Okay, another example of a situation where DID can be used is when there is a school feeding program by a government, and let's say we want to see the effects of this school feeding program on the performance of what? Of students. Okay, we can use DID in this scenario also. So DID is typically used to estimate the effect of a specific intervention or treatment, like I mentioned early on, such as a passage of law, enactment of policy, or large-scale program implementation, by comparing the changes in outcomes over time between a population that is enrolled in a program, in this case referred to as the intervention group, and a population that is not involved or enrolled in the program, which is referred to as the controlled group. Yes, so this diagram gives us a clear picture of how DID works. And in DID, we are interested in looking at the effects of an intervention or a program or a treatment before the implementation of that program or treatment, and then after. So this is a pictorial view of a DID estimation. So if you can see, we have two lines here, and this green line is used to represent our control group. That is the group that did not receive any treatment. And then this red line also represents the treatment group. That is the group that the policy affected, or the group that received a particular treatment. And this portion or this area represents the effect or the difference between the treatment and the control group prior to the implementation of the program, or prior to the enactment of a policy, or prior to the treatment time. And then this region also represents the effect of the policy after it was implemented, or let me refer to as this region is seen or known as what? The time period after the treatment. I will come back to this diagram to give more explanation about it. Now, I would want to talk about the situations or assumptions underlying difference in difference estimation. What are the things that you are to look for before you can use a DID design for your research? What are the things that you are to look for before you can use a DID design for your research? The first assumption is the parallel trend assumption. And the parallel trend assumption requires that in the absence of treatment, the difference between the treatment and control group is constant over time. So we would want to look at the impact or the effect of a particular program on two groups. One group is known as the treatment and the other group is known as the control group. But the assumption here is that before the treatment, or in the absence of the treatment, these two groups that we want to compare their performance or the outcome of the treatment, they must have a consistent outcome, or their outcome must move in a parallel dimension. When we go back to our diagram, we could see that if you look at the straight lines between the control group, that is the green line, and then the treatment group, we could see that they are moving in a parallel direction. Okay, that is prior to the intervention. And then after the intervention, we know that there is a change in the direction or movement of the treatment group, and this is as a result of what? Of the treatment. So in this case, then we can establish that the treatment, the change in the movement of the treated group is as a result of what? Of the treatment that was given. Okay, so without this assumption being established, we cannot go ahead to use what? A difference in difference design. So one of the tests, okay, or let me say robustness test, or one of the checks that you need to do before you go ahead with your DID estimation is to use econometrics method to find out whether these two variables, that is your two groups, that is your treatment group and then your control group, are moving what? In the same direction with respect to what? A particular observation, or with respect to a particular variable. So like I said, the violation of the parallel trend assumption will lead to a biased estimation of the causal effects. And the parallel trend assumption is the most critical of the four assumptions to ensure internal validity of DID model and usually it is the hardest to fulfill. That is in reality. So like I mentioned, we need to make sure that there is a parallel trend between the treatment and then the control group before we can establish a causal effect relationship. Now, apart from the parallel trend assumption, the next assumption is that the intervention is unrelated to the outcome at baseline. In other words, what we are saying is that allocation of intervention should not be determined by the outcome. Most of the time, if you have read about DID before, or this is your first time, we always say that the treatment should always be exogenous, or let me say, what you want to assess the impact. If you want to assess the impact of a particular policy, of a particular program, of a particular law, then that policy or law, that treatment should not be determined by the outcome. Okay, so most of the time, if I am to use a firm, a corporate body as an example, we always look at exogenous shock. We always look at the effects that are usually coming, or the shocks that are usually coming from either the industry or from regulatory bodies or from the government. Okay, so for instance, if there is a change in tax policy by the government, this is not internally determined by management. And for that matter, once the change in policy or tax policy is coming from the government, we consider it as exogenous. And this exogenous shock has an impact on a lot of variables of the firm. So in this instance, if we want to check the impact of this treatment or of this change in tax policy on any company variable, such as revenue, such as earnings, or any other outcome of the company, we can use a difference in difference design, because our treatment or the intervention is exogenous. Okay, so that is one assumption that we need to take note of. Another assumption is that the composition of intervention and then the comparison group should be stable, or is stable for repeated cross-sectional design. Okay, we must ensure that these two groups are stable. If they are unstable, then it will be difficult for us to do a comparison or establish a cause-effect relationship. And then also the last assumption is that there should be no spillover effect, okay, between the treatment and the control group. Whenever the treatment is given, we don't expect that there is a spillover effect. What do we mean by a spillover effect? For instance, let me go back to the example that I cited concerning a program that was being given to physically challenged people in an organization. If at the end of the day, the training program that was given to this category of workers, they also transfer the knowledge or the training that they receive to other workers who are also not physically challenged, then there has been a spillover effect. If you want to check the outcome or the performance of these two groups, although the employees who are not physically challenged did not partake in the training program, but because they received knowledge or they received some kind of assistance of the training from their colleagues who participated in the program, then there has been let me say the effect has been neutralized, okay, if I may put it that way. If we want to compare the outcome of the training program between these two groups, already there has been a transfer of knowledge. So our estimation or an analysis will be biased. We would not know the true effect, okay, of the program or the true outcome of the program, the performance of employees, the change in the performance of employees. That was as a result of the training program that was organized. So in DID design, we must ensure that the two groups that you have chosen for a particular program or a particular law, there are no spillover effects. Now let's come to the regression model. This is the regression model for difference in difference design. And in difference in difference design, like I mentioned earlier, we are interested in the change. We are interested in the change between two groups, that is the treatment group and the control group. And the change that we are looking at, most often our concentration is the change after the treatment or after an intervention, because prior to the intervention, these two groups, that is the treatment and the control group, will be moving in a parallel line or in the same manner. So when we look at the difference, the change of the results, okay, after the intervention, then that is what we are basically interested in. So looking at this regression model, we have beta 0 y, that is our output or outcome variable, is equal to beta 0 plus beta 1 post, and the post here is a dummy variable that is representing the period after the intervention, and then the beta 2 times treat, which is also a dummy variable, that is taking care of what? The groupings, that is the treatment group and the control group. So in this case, if a particular group received the treatment, it is denoted or assigned the value of 1. And then if the group did not receive, it is assigned a value of 0. And so we interact the post and then the treat dummies in order to get what? Our coefficient for the difference in difference. So this beta 3, that is the coefficient of the interaction between post and the treat dummies, gives us the actual difference in difference estimation. Okay, then we add our control variables and then our error term. So basically this is the simple regression model that is being used, and we apply this same idea, this same model in most of our research, specifically in accounting and finance or economic research. Most often this is the baseline regression model that we adopt. Okay, so if you look at this diagram, B1 is represent the change in what? In the timeline for the control group. B2 represents the change between the treatment and the control group prior to the intervention, and then B3 represents the actual difference in difference. So if I may show you clearly, B0 is our baseline average, B1 is the time trend in the control group, and then B2 represents the difference between the two groups, that is the pre-intervention, and then B3 also represents difference in changes over time. Okay, so for us to get a clearer understanding, I'm going to give us an example, and then we see, let's say in this hypothetical example, there is a particular country, let's say country A has a tax policy or a VAT policy for manufacturers and then wholesalers, which is, let me say, 20%. Okay, a VAT rate of 20% for both manufacturers and wholesalers. And then in a particular year, the government decided to change this tax policy to reduce the VAT rate for wholesalers to a flat rate of 5%. Okay, in this case, we can use DID design to check the impact of the reduction in VAT policy for wholesalers on their revenue or their earnings. Okay, so I'm going to illustrate this. We are having two groups, manufacturers and then wholesalers. Prior to the tax policy, they were both charging 20% VAT rates on their supplies. And now the government brings a change in the VAT rate such that wholesalers are to charge a rate of 5%, whilst manufacturers maintain their original 20%. So in this case, there has been a reduction in the VAT rate that is being charged by these two groups, okay? And we can use DID to do analysis to know the effect of this tax policy on the company's revenue or the firm's revenue. In this case, as I said, this intervention is exogenous. The change in policy was done by the government, but at the end of the day, firms are being affected. Okay, so we want to see the impact. So now our interest is on the difference between the manufacturers and then the wholesalers' revenue, as well as the difference in their timing, that is before the VAT policy and then after the VAT policy. So in a typical empirical research, we will have a panel data, okay? And when we have a panel data, then obviously this regression model, we will have a subscript of IT representing the time and then the firm observations, okay? And then also, once we are interested in finding our estimates for the difference, that is before and after the intervention, then we'll be interested in the coefficient, that is our coefficient estimate. So what is going to be the beta hat at each of these sections, okay? So if we look at this particular region, like I explained early on, our beta 1 in this example, in this scenario, is given treat, and treat refers to what? Is a dummy variable, that is 1 if the firm is if it's a wholesale, okay? If 1 refers to wholesalers and then 0 refers otherwise, okay? And we have another dummy variable post, which is 1 represents after the intervention and then 0 otherwise. So if we are in this particular time, or we are in this particular region, that is before the VAT policy, then our control, that is manufacturers, okay, manufacturers have 0, and then is denoted by 0, and then before VAT policy is also 0. So our estimated coefficient at this point is going to be beta 0 hat, okay? It's going to be just beta 0. And then if we also come here, we have the treatment, that is wholesalers, they are assigned 1, and then before the intervention is is 0. So automatically, if you interact, we are going to get here as 0. So our estimated coefficient is going to be beta 0 plus beta 1, okay? In this region also, our estimated coefficient, that is control group, is 0, and then after the estimation is is 1, okay? So we are going to have beta 0 plus beta 2, okay? That is the post after the VAT policy. And in this scenario, that is the treatment wholesalers after the VAT policy. So in this case, we have 1 and 1. So we have 1, 1, and then the treatment and the post interaction is also given. So we are going to have beta 0 plus beta 1 plus beta 2 plus beta 3. So in this case, then we need to establish the difference in difference. So first of all, if we are looking at the difference in the timelines, okay, here we are just subtracting before the intervention, the coefficients we had before the intervention from after the intervention. So B0 will cancel B0, and then we have B2. When we come to the treatment group, B0 cancels B0, B1 cancels B1, and then we will have B2 plus B1. So obviously, if you are to find the difference here, I believe your guess is as good as mine, okay? Now, when we come to the difference in the two groups, that is the control group and the treatment group, we are deducting the control from the treatment. So this one cancels this, and then we will have beta 1. And then also we cross B0 and then B2 out from here, then our answer will be what? B1 plus B3. So when we want to find the difference here, B1 will cancel B1, and then we have what? B3 here. The same as what? B2 cancels B2, and then we have B3 here. So this beta 3, that is the coefficient of the interaction term. Okay, that is the treatment and the post. This actually gives us what? The estimation, okay, of the difference in difference. Okay, basically this is what we are interested in. All right, and then in a particular experiment, or let me say, if you are dealing with a situation where you have fixed effects, okay, now remember that when you are using this model, you have to also introduce your control variables as well as your error term. Okay, yes, but if we want to bring fixed effects, okay, for example, we want to control for firm fixed effects and then year fixed effects. In that case, if we are bringing those fixed effects into being, then we need to suppress one of these dummy variables, okay, because econometric technique will always allow us to do what? Only suppress one of these variables before we can plug in what? The year fixed effects and then the firm fixed effects or industry fixed effects at the same time. If not, our regression estimation cannot be done. So we must take notes, okay? You must take notes that whenever you are running a regression and then you have your treatment dummy, your post dummy, and then the interaction term, as well as other control variables, then you can run your regression. But if you also want to control for year fixed effects, then it means you must suppress this beta 2, that is the post dummy, okay, so that your regression model will work, and then your concentration will be on what? The interaction, the beta 3, that is between the treatment and then the post, the interaction of these two, okay. So we must take note of that. Whenever you are including firm fixed effects and year fixed effects, you cannot bring all these dummies and include that. You must suppress one. So you must take note of this. Now we want to move on to the strengths. What are the strengths of using DID design? We say that it is what? It has an intuitive interpretation. Like once you understand it, it is very simple to use, simple to understand, and you can make logic from it. We want to establish a cause and effect relationship. So once there's a parallel trend or they are moving, they have a constant movement, okay? I mean, I'm talking about the treatment group and the control group. Then as soon as there is a change after a shock or after a treatment, then we can say that we can estimate that the difference coming between the two outcomes is as a result of what? Of the treatment, okay? And we can obtain a causal effect using an observational data if we meet all our assumptions. So DID design is very simple and then easy to understand, okay? And this design can also use either individual or group level data. So you want to check the difference between different firms or let's say different industries, okay? You want to assess the impact of a particular shock, of a particular policy, of a particular law on firms in different industries. DID will also allow you to do such comparison or such analysis, whether you are using an individual or a group level data. And then also comparison groups can start at different levels of of the outcome. In DID, our interest is in the change that occurs. We are concentrating on the change after the intervention and then the change before the intervention, so that we can draw a conclusion. So we are not interested in absolute levels, but rather the change that occurred between the groups of concern. And then DID also accounts for change due to factors other than the intervention. So once we are able to establish that prior to the intervention, this was what was happening, after the intervention, this is the actual difference in difference, then we will be able to know that, okay, without the treatment, this would have been the difference. So DID design is able to help us to know the change due to factors other than the intervention or the treatment. And then also it of course have some limitation. That is, if you don't have any intervention group, you cannot use a DID. So you cannot use a DID for only one particular group. Always, whenever you think of DID, then you are looking at a target group and a control group. So these two must be obtained. And then it cannot be used if intervention allocation was determined by baseline outcome. Like I explained early on, the intervention should always be what? Exogenous. So if your intervention, if your treatment is internally determined, especially if firms have control over the timing of a particular policy or a particular training program, then using DID will be a challenge, or there will be a bias in the estimation, because there is going to be a lot of what? Endogeneity concerns. Okay, but once we have the intervention coming from outside the firm, or once the shock is an exogenous shock, then we are able to eliminate a lot of what? Endogeneity concerns. And then we also cannot use if the comparison group have different outcome trend. Like I mentioned, one of the assumptions, we must make sure that the comparison group, that's the treatment and the control group, they are moving in a parallel line, and they are what? Constant or stable over time. And then we cannot use if composition of group, that is pre and post, are not what? Stable. So they must be stable. These are some of the papers, as I mentioned before the presentation, top papers that have employed DID research design. So you can look out for these papers and then read more. So from the current paper, even we have papers in 2021 that have used DID research design, but I just chose few of them. So for 2020 paper by Chen et al., that is Corporate Governance and Cash Holdings, which was published in the Journal of Corporate Finance, you can find this paper, and the authors use what? DID in researching on corporate governance and cash holdings. Favor et al. Is also a renowned paper published in 2017 in the Journal of what? Financial Economics. Then Donald and Lang, 2007, that is Interference with Difference in Difference and Other Panel Data. This is also another good paper for further studies. And then Bertrand, Duflo, and Mulianathan, 2004. You can also look out for this paper in the Quarterly Journal of Economics, where they research on how much we should trust difference and difference estimates. Yes, you can also check on CAD, the impact of Mariel boat lift on the Miami labor market. So DID research or DID design has been used from early 1990s, as far as 1984, 1990, in the year 2000, even 2001, there are papers or publications that authors have used this research design that you can also download and then get further knowledge or understanding about DID design. I believe that this presentation has been very impactful, and this is going to be the end of today's presentation. In our next presentation, I will introduce you to propensity score matching. If you look at most of the papers that used difference in difference design as a robustness check, they go further to also do propensity score matching, that is, use PSM approach to ascertain whether there is no selection bias between any treatment and then control group. So our next presentation will be on propensity score matching. Thank you for your time, and see you in the next presentation.